Hi, Vapsaya. This video series I'm starting is one of the most comprehensive Godot beginners tutorials that you'll find for free on the internet. We're going to be exploring all of the basic Godot topics, starting with today's video in which we're going to be learning about creating your first character controller. If you aren't interested in the series, you can just learn to create your first character controller and don't watch the rest videos. So let's get started. In a new Godot project, I'm going to be going and drag and dropping the assets folder, the art I'm going to be using. Let's just do it. Let's create some folders. I'm going to be creating an asset folder, scenes folder for organizing, and scripts folder. Then just for some resources, let's add a resource folder just for basic stuff. Let's just go ahead and create we need some project settings first, so let's just drag and drop the player. For me it looks crisp and sharp, but for some people it will look blurry because the texture filter is set to linear. If you go to the resources and search for rendering and go to texture, you can see by default it's linear. Do it to nearest so your pixel art is nice and crisp. If you're not using pixel art, just don't do that. Let's go ahead and create a new node by clicking other node and add a character body 2D node. This node is a basic physics body which is ideal for creating characters like player. Let's add a collision shape 2D node. This node is for adding collisions. We'll add a collision shape, but before that we need something of visuals. Let's add an animated sprite 2D node. And by clicking this empty and clicking on it, you can open this drop down. This is your basic animation system. You can see these in any kind of animation software. These two buttons are for inputting, and by clicking the grid button and going to the player, we can just open this file and we can cut these file into frames and select our idle frames. I'm doing this really fast because I just want to explain the code more. You can find videos on doing all of these on my channel. So let's go ahead and rename this animation to idle. Make sure you remember the name. Let's create our run animation by clicking that button above. Let's create a jump animation and a fall animation. By clicking this grid icon, you open a sprite sheet, which is a collection of sprites, and you select the frames by cutting them. You can adjust the frame rate. 6 or 7 is good. And let's go ahead and add the jump frame. You can zoom in by holding control and scroll wheel, and I'm going to be using one frame for rising up and one frame for rising, like falling down. This is for rising up. Make sure you use the animations you want. This is rising up, and let's go ahead and select the falling down frame. Okay, we got all the animations set up, and let's create a new collision shape. Select the drop down and select the shape you want. For a tip here is to get it above this shape, and by selecting this debug color, if you take the A into the right, it will become transparent and only the outline will be left. This is just for good looking, because I don't like the bluish color, so I just mostly just take it to 0, so it's just an outline. But you can just keep a little tint or just keep it full, so it's a block. You can use it for debugging, and just a blue little color for good looks. And we got our animation set up quickly. You can watch more detailed videos, but it's just pretty simple if you have used any kind of video editing software. And you can just put it easy by clicking S. We save it into the folder we want, and we get the player scene. We're gonna go pretty slow, but I just want to set up these scenes, things that I'm gonna be explaining in later videos. So just keep that in mind, that these are things I'm gonna be explaining more in later videos. I just want to explain the Godot, the player character code more, and we're going to be exploring all of these. None of these here you need to think about. This is, I'm just setting a simple platform so the player can walk around. I'm using a static body 2D. So what I can do is just drag one of my tiles. These are supposed to be used in a tile map. I'm just gonna drag it here. As I say, I'm just doing it for looks. So come on, I'm making a YouTube video. People don't like bad looking videos. Just adding a background here. It's just a simple image, and you can do the sorting like that. None of this matters. I'm gonna be teaching you all, but if you can follow, you can follow, but you just don't need to do any of these. I'm just setting a simple thing so we can collide with basic thing. Now what I'm gonna do is I'm gonna go ahead and clicking the link icon, bring the player scene here. If I run the player scene, you can see nothing happens because we need to add a camera. You can see this looks really bad, so add a camera 2D node and just drag and drop it in the center. You can add the zoom value so it just looks good. As I said, games are about looks, and sometimes if your game doesn't look good in the start, it just ruins the motivation. Even if it's a project where you don't need to do any designing, just for some looks. Okay, the player doesn't fall, doesn't walk, anything like that. And what I'm gonna do, I'm gonna create a new script by clicking that icon and save it right here and hit create. And you can see that this already has some code. This is code provided by Godot. It's just basic platformer code. I'm not going to use that, but just for demonstration. You can see the player just fell off. The reason is that it doesn't have a collision shape, and that's what I want to teach you here. A collision shape is a node that we added earlier that collides with other physics bodies. We use it under physics bodies like character bodies, static bodies, to make it collide with. A version of collision shape is polygon shape, which is a customly drawn collision. A variation of that could be a collision shape that is a predefined shape. Let's add a collision shape, and you can see it's a predefined shape. It's added up there. You can just drag and drop right here, and you can just fit it here. Using a collision shape is more performant because using too much like corner or polygons is not good for performance. But if you are creating a polygon that's just simple, you don't need to do that. I can click the I button on the side to hide these so it doesn't look that bad. And yeah, we get a simple platformer. We can do really advanced stuff like animation, all the stuff like that, but this is just some demonstration. Okay, back to the player scene, and let's now just get started with the real stuff. I know all of that could be daunting to beginners, but you don't need to, do any of that I showed. Let's just go ahead and go to the player scene, and you can click the button on the player script right there, or you can go to the script editor on top. Just saving the scenes. You can see the scenes are saved now. Now what I'm going to do is I'm going to go to the player script here. Let's clean that by clicking that brush icon and hide that, and let's just start coding. Okay, let's go ahead and code the thing. Let's create a variable. var is the code for variable, and you can name it anything you want. Now I'm not gonna create just a variable. I'm gonna backlevel and I'm gonna type at export and export variable, export and then variable, or I'm gonna name it speed. Now speed is gonna be the movement speed. Then you can add these 2 dots, double colon, or anything you call it, and you can now type the classification, the type of the value that's a variable is going to be. I'm going to type float. That means it's going to be a number with decimal points. You don't need to add a value. You can add it here directly in the editor. So let's just leave it to that. Let's create another one. At export variable var, and let's name it jump force. You can add an underscore because you cannot use spaces. ORCA. Okay,
jump force. Again, let's add this column and define the type. This is so you can, if you don't want to define the type, just add a value to it, any value, 0.0, and then you won't have to like define the type. Godot will itself figure out what type it is. But just if you add this colon, this way the type will become like static. This means in game, no one using code will be able to change the type of this variable, which is actually possible. You can store the value and it changes the type. So adding this will actually static the type. So no other type of value can be stored in this variable. That's just advanced stuff. Let's just do it. I'm going to add float and just like that. Let's create another variable, which is export. Now back up a little. Now see how I'm not typing the whole thing. I'm just using like autofill. How I use it is when you type something, you get these recommendations. The highlighted one, which you can highlight by clicking on them or using arrow keys to go up and down. And don't enter. No, you can enter, but the easy thing is just when you type at or any word and the suggestion come, hit tab to write the selected one or the topmost one and tab. Okay, let's type var and gravity. I'm going to be naming this variable gravity. Okay, I'm going to be float again. And just like that. Let's go ahead and create our reference. Reference to what? Reference to our animation. Now, what is our reference? Now, the whole structure of Godot is based on nodes. You know that much, I'm sure. Now, the thing is, each node operates differently. It has all of these different properties, and you can use these properties like these. You can see under animation we have the sprite frame, and when you hover over it, it shows you this property. You can use this property and develop logic with it. For example, you have this animation property. It tells you the name of the animation that's playing. You can change this to change the animation of the player. For example, we have the position property. This lets you change the position of the player. Rotation, scale, skew, then visibility, if it's visible or not, ordering, like if once what is in front, it is not. And the texture, you can like change if it's blurry, if it's like crisp, repeats, materials. So all of these is properties, and you can like change these properties to create logic. Now, for changing these properties using code, you need to create a script, and we don't want to use a script for each and every node, so we use a script and customize the properties of one node into another script. Mainly like this guy is the parent of these nodes, so we can just easily customize all of the children's properties in this script. For that, we need a reference. We need to tell which node are we talking about, and how this way we can get properties of these guys. The referencing is kind of the main structure and how Godot works, so definitely you need to keep it in mind. Now, how we add a reference? Technically, it's pretty easy. You click on the node you want to reference and you drag it here, and there's your reference. But we need to store this reference in a variable, which is totally optional. You can use it directly, but you can add a dot after that, and you can like search any property you want. Right now it's not working because we need to do it in a function, but just for example. Now, storing it in a variable lets you like easily use it, and you can swap the properties. Like you have one node for animation, we don't want to use that node anymore. You can change the reference with another reference, and you don't have to like change the whole code. That's just for productivity purposes. So what you can do is create a variable, and you can name it like animations, and you can equal to, and drag this reference here. Pretty simple, but the thing is, the references are not actually itself the data of these nodes. This is kind of the location. It's telling this variable that at this location, all of the data about this node is present. Now we need to retrieve that data. How we do that is using processing. And when do we process? When the game is running. Right now, the variable knows nothing. So we need to tell it that when the game runs, retrieve the data from there. How we do that? We just add an at. You can add an at on ready. That means on the game running, like when the game runs, go to this location and retrieve the data of the animated sprite 2D, so we can use it later. You can create a reference like all of these code in seconds. You can just delete it and click on this, drag it here. Before releasing, hold control, and there's your reference. You can rename these words to what you want. I'm just gonna call it animator, and just like that we got a reference. And let's go ahead and start working on the movement, jumping, and all kind of test code. Let's create function, func, for func or function. Now functions are processing ways, how we process some kind of code. That means how a code is executed. Let me explain it a bit more. I'm going to create a physics process function. I call it the physics process delta function because it uses delta. Now delta is a complex thing, but it's basically the time in our real world elapsed from like the previous frame, since the previous frame. So it's a bit of a complex thing. I'll leave a link to a really nice video that explains it for the computer nerds, but I don't think you need to learn that right now. Just think that you need to multiply it to everything. It's just a meme in the gaming world. So let's go ahead. I'm going to teach more about it. You don't need to worry about that. If you are on this block where this dot is and you hit enter, you will create this thing. We call it the tab, and you can create another one by hitting tab. Now what this is representation of inheritance. What that means is the code that's written here will only be executed or like used if this line, like this function is running. So it's like representation of parenting. So all of the code inside here is the children of this function. So long as this function running, all the code inside it will be running. So this one is responsible for the execution of anything here. This tab represents that. Any code that's written here doesn't matter to this guy. Let's go ahead and create an if statement. Now, why we want to create an if statement? Because of course we want to check for conditions. We can check for many kind of conditions. One I'm going to be checking it is if the player is on floor. You might think it's quite complex, but Godot makes it easy. Now, if you hold control and go to the character body 2D written here and click on it, it will open the online documentations, like the offline documentation. This is a mini tutorial built in Godot, so you can learn about anything. These properties, methods, these are the building blocks that you use in coding and Godot to create any kind of logic. And we need to remember and master all of these. Might seem daunting, but in some time you'll be the Godot master. Now one property we're going to be using, which is under the character body 2D. Notice here this tells that the character body 2D here inherits from these guys. This tells it which one inherits from which one. So this is under the physics bodies. So this one, character body 2D, used to be called kinematic body 2D and has the kinematic features. Now, one cool method. Now, there's two kind of things. There are properties. Properties are built-in variables. You can change their value like if like these are a lot of things like velocity here and platform layers, some things like that. And these are built-in variables. These are variables that were created in Godot, and they hold some kind of functionality. You can chase these. This can be something like making something true, something false, and things like that. Now, methods are built-in functions. What that means, they have some built-in code inside them that you can utilize. What that means is like a function called isOnFloor. That means there is a logic setup to check if something is beneath the player. You might think that's so hard to implement, and Godot has implemented that for you. In some other engine, you might need to like implement all of that stuff, but in Godot, we have all of these. That's why Godot makes coding so easy. Now, I'm going to be using this isOnFloor function, which what it does is checks if the player is touching something from the below. It doesn't care about this sprite, it cares about this guy, the collision shape we set up. If the bottom of the collision shape is touching some other collision shape, and that's where the static body here comes in. The static body interacts with the collision body because static body is a physics body as well. So that's how all of the nodes interact with each other. We'll learn about more in future tutorials, and I'm just telling you right now, my tutorial is going to be really detailed, so if you don't have the time to listen, I don't think you want to learn. So let's go back to our code. Under here, let's write if isOnFloor. isOnFloor returns a true or false. So that means if this one is like true, then we're gonna be executing some code. Now let's add this one here, the double colon right at the end of the condition. Now why do we want to add that? This tells Godot that any code between this and the colon is the condition that we want to check for. So we have the condition that the player is touching the floor. If you hit enter after we are on this block, we have another tab appeared automatically. Now this tab shows that a code that's written here is governed under this one for first, if first of all it's governed under the function. That means if the function is running, then this code will run. For secondary, it's running under these if statements. That means if the if statement is true or running, then the code here will be executed. This inheritance is the base of Godot, and you need to learn it. Now let's add some code here. If it's on floor, we want to if it's not on floor, if it's flying, and we can add a not. If you can just type not. Godot is just too intuitive. You can just type not. If not floor, but you can just do is you can type this one, an exclamation mark, and you can see it's working, but it's just telling us to add some code in results of the function. Let's add the code. I'm going to be doing is I'm going to just set the velocity, which is our built-in property, which is our variable. You can see it's a property. P shows variable. Just forget about variable. Property, just call it a variable. All of these are your properties, the properties you have created. Let's use the property variable. It's a vector too. Vector math is kind of a complex thing. Not too much of a complex thing, but you need I need some time to explain it, so I'll explain it in later videos. Now velocity has two values, the value of x and a value of y. We just want to talk about the y value, which is up and down. What we're gonna do is we're gonna add to the y value. What we're gonna add gravity, so it's gonna fall. The value of gravity, if we equal, should be minus, it's gonna be minus 400. For example, most of the time in real world, if you just convert the real gravity of this world, it's kind of 980 pixels per second or per frame or something like that. It's just 980. I don't think about too much stuff. So, and what we're gonna do is we're gonna multiply it by, our good old friend delta. This way, the falling, if the gravity is being applied, the falling of the player would be completely, natural. The thing is, process function can be influenced by your frame rate or your computer's potato, then you'll play with jitter, stuff like that. We don't want that to happen because we want the player to move in the time, according to the real time. So we multiply everything by delta. Just work with that. Now, one thing to explain is why gravity, because gravity is down, it should be, gravity should be positive. I'm really sorry. Now, the thing is, in Godot, down is positive, up is negative. You need to remember that. By clicking this icon, you can go to the script directly. Just a tip here. Now, we can use this code, but nothing will happen. If we run this code, we are in the main scene, and we're gonna Control S, and I'm gonna run this scene, and nothing will happen. Why? We applied code for the player to fall. If the player is not on flow, it should fall, but it's not falling. The thing is, in the process function, we also need to tell the Godot that we want to process movement. How we do that? We use a function, a built-in function, or a method called move and slide. This just is a method you need to add. There's nothing much you need to do now. It just tells Godot to process movement. I don't have to explain much more. You can just hold Control and click on it and learn about it more. But that's just kind of it. You run the scene again, and it's falling. It's colliding with the objects because we added a collision shape. Nice. Oh, nothing else happens because we haven't set the code. Let's quickly move to code now. So because we don't want to waste your time too much. Now let's handle jumping. If you add a hash, you can add a comment. Comment is dummy code. It doesn't work. It doesn't do anything. It's just a note for yourself or anyone else who watches your code. Let's handle, jumping. Now, jumping is simply opposite to applying gravity. Instead of adding a positive number, we just add a negative number. So what we do is for jumping, we need to add a condition. When we want to jump is when we press the space button or any button like you want to jumping with. But for that, we need to set up input actions. Let's go to project settings, and in their input map, you can see I have some by default. Let's delete them. I used them before, so there's nothing here. This is the one that you'll find. So let's just cut it and let's do it again. Project settings, and under you're going to be in general, go to input map. This is the area here. You can search them but unfilter them, and you can click here and type the name of the new input pad you want to create. Let's create one for jumping. Jump, and name one and enter it. And input map is created. You click this to assign keys to this input. That means we're telling that if we want to jump, which keys we want to use. And listening for input means that any keys that you press while this thing is, selected will be declared as an input. I'm gonna space, and now it's space, and okay. Now one is added. We can add more. That means if you press space or another key, I'm gonna add the up arrow. You can add another one. I'm gonna add the W, just for fun. Let's close that. And now we can check for input actions. We can check if that input action, an action is kind of a representation for multiple keys. That means if this action is performed, If this or any of these is pressed, we'll say that a jump action has been performed. It's just nothing but a name for multiple keys and a way to check for multiple keys at once. So we're going to check for if input dot is a way to access properties of classes. Input is another class. There are too many classes. I can just not tell you one, like explain them in one video. A good way is to learn about a class is again holding control and clicking on it. If it's underlined, that means there's an explanation there, and click on it and learn about it more. Now the input class has some built-in methods and properties as well. One is action just pressed or is action pressed. Just pressed means it's kind of like a one-time click. For example, if we want a space, we don't want the player to hold the button for us to know that he wants to jump. He just clicks the button once and we jump. So just press is like checking if the player has pressed it. So there's nothing more to it. Even if the player is holding it, doesn't matter. But if you select pressed, it's like also checks if the player is holding down the button. For jumping, we just need just pressed. There's another one called just released. That means even if the player is pressing the button, doesn't matter. Once the player lifts their hand off the button, there's just a slight signal there. Oh my god, like they just released the button. It's like that. Okay, so just pressed and select it and hit tab. Now in these parentheses, we select a function. So our action. So is action, that means which action? Jump action. There are some built-in actions like a UI, which is UI accept represents space, UI cancel represents the escape button, and there are a lot of buttons. Let's just select jump. This is the custom one we created. Add enter or tab, anyone you want. You can manually type it like in the double quotations and the name that you wrote up there in the project settings, and tab for jump. That means whenever this function is like pressed once, there's gonna be this for that split movement or that split frame, the condition here will be true, and the code that we enter in this if statement will be running. Let's add that thing. We add a double colon and enter to go inside the if condition. And now what we want to do is, of course, we want to subtract some, we're going to add some negative force. Let's go to jumping and add a negative 400 as our jump force. So what we do is we add a, in the velocity dot y, we plus equal, that means we add jump force. Now jumping, like adding is well and good, but I think you don't need to add that for velocity, because while we are on floor, there's nothing there. That means the gravity isn't being applied. That's why we just add the make the jump velocity dot y to jump force, and we can just multiply it by delta if we want. Let's just don't do that. But the thing is, we won't want our player to be able to jump while it's in air. This way it can just keep pressing the buttons and float in the air. We want them to jump when they are on the floor. So you can add and yeah, Godot is just too intuitive. And that means it's checking for two conditions now. You can just like and. Now there are two things like and or. That means either this condition to the right or the condition to the left is true, but and means both of the conditions should be true. I'm sure you have learned it in basic computer science. I did. So and is on floor. That means the player is pressing the button for jumping and is on the floor. In this condition, we'll make the player jump. And yeah, this is the simple code for jumping. And it technically should work. And you know, it's jumping. You can adjust the force of the jump by, I'm going to do 200. 200 should be good. And we run. And yes. Now I think I haven't mentioned the running thing. Now when you are in a scene, by clicking this scene, we run the main scene. Which is the main scene is selected. You can go to the scene and this is highlighted. You can right click and set as main scene here. You can click on this function, like if you want the player function to be set as main scene, you can set it as a main scene. Since our main scene is the main scene, every time we press this button, the main scene will be executed. Just a good thing to tell you. Okay, let's move on to movement. Movement left and right. Let's go hash movement. Movement. I'm bad at spelling. Okay, now how do we move? It's pretty easy. We add or subtract something to the x and y velocity. It should be obvious, you dum-dums. Okay, so what we need to do is we need to check for some input left and right and add and subtract movement. Pretty easy. Let's make it complex. Why? We are not chumps. Since you understand the concept of using if the input statements, you can copy and paste this code. You can use the else if for checking multiple things. I'm pretty sure that's just understandable now. Let's use a new way of creating movement. This is just so you can explore more concepts. There are some functions more in the input class. For example, we can create a variable inside the thing and I'll call it direction. Direction. Now, the direction we can make it equal to a property or a method. This is just to tell you that you can like directly drive some kind of input in like value in a variable by using a method. But a method I'm going to be using is called the input method. Let's type input, and I'm going to check is get axis. This is one of the function. Now, if you have a brain and you are smarter than me, you should ask a question me right now. Wow, sir, you ask for input in an if statement. That means the function was telling you if there is an input in an if statement. That means it should just tell you whether it's input or not. So it's a two-way condition, whether it's 1 or 0, or if it's true or false. And I said it, when a condition is true, this number gives 1, or if it's false, it gives 0. Now get axis gives 3 numbers. What? Let me explain. Now it takes 2 arguments. That means 2 values here. The get is action press takes 1 value, which is this. Just like 1 here, it takes 2 actions. Let's create 2 actions more. And this time for movement, let's create move underscore left and enter. Now, one thing I often happens to me is that I don't know in the A and W key which is left, which is right. So I just press the arrow keys. So if I'm creating left, it's gonna like left arrow, and it's gonna play the right arrow when I press the right arrow, things like that. This is just to know which direction is which button. Neat little trick, really gonna be useful to you. So for left here, that means the same is, it should be A. I know sometime I rubble through my talking, so I'm not clear, but just try to understand, guys. I'm a non-English guy. So we got move left, move right. Okay, move right, and let's press this button. Let's do it D, and let's do A. Let's use it faster. We're running out of time. Okay, so I'm gonna give it, now what it does, I'm gonna give it 2 of these values. I'm gonna do move left, and comma, and move right. Now, while we are blinking, like I call it blinking when the crosshair is blinking inside this thing, you see this under here. You can also go to the documentations and see that getAccess takes 2 values. It's input actions, and returns are either a 0, a 1, or a -1. That means if the action which is placed here is being pressed, it's gonna return -1, and if this one is being pressed, it's gonna return +1, and if no one is being pressed, it's gonna return 0. Now, if you go into the positioning here, you can see if the player, if you change the position here, let's go to here, and if you change the position of the player under transforms, you can see that in the X position, if the position increases, the player goes right, and if decreases, the player goes left. That means we need to go negative for left, and we need to go positive for right. So negative increment for left and positive increment for right, and it's gonna return either 0 or 1. That means positive or negative, and we can increment it into the velocity. I'm pretty sure you can understand what I'm saying when I do this. We can do it velocity dot x equal direction multiplied, because it's 0, 1, or minus. If you add this small value, because it's a value of 0 and 1, the player will move, but really slowly. So we need to boost the speed by multiplying it to a speed number. Let's multiply it by speed, and it technically should work, hopefully. And let's run the scene, and boom, it's not working. Yeah, we messed up somewhere. Oh, yeah, we didn't add a value to the speed. Yeah, suckers. Let's add a value of 200. Just positive 200 is gonna be good. And boom, we're moving. But we're not moving. Oh, we're moving. And I think I messed up somewhere while setting the keys. So it's moving, but the keys are just a bit of problem here. I messed up here. So yeah, let's go and delete this. And for A, D, and for right, I just messed up there. I'm pretty sure you must have noticed, but I didn't. Okay, let's run it again. Second time's the charm, and it's working. And we'll go down. Okay, let's just not get excited and move on. Let's just go to the final part of the long journey, which is animating. Now let's create another function just to teach you about, yes, user created functions. Let's create a function, and this time instead of using a built-in one, we create another, like a custom one. I'm gonna call it animate. Add 2 brackets at the end to tell that it's a function, and the signature mark, and boom, enter the function. There's no functionality to this function, it does nothing, and we're going to define the functionality, which is going to be animation. So what we're going to do is we're going to use this direction variable up here to determine the if the player is moving left or right, and we're going to use that to animate. Okay, it's going to be a long journey. Okay, so if direction is not equal to 0, that means there is some value, there is some kind of movement, then what we see is gonna call the animator again, animator, oh my god, okay, animator okay, dot flip page. What is flip page? Let me explain it in a bit. So equal, this flip page is either true or false. So what we're gonna do is equal direction smaller than 0. Do you understand it? How it works? Come on, take a minute. Okay, so it's a really nice. It's just a way to shorten the code. So it's like kind of a toggle button for flipping horizontally or not. Now what we are flipping is, let's go to the sprite. Now you can see that this sprite is facing right. So of course when the player moves left, we want to face the other way. So we just flip them by using this function in the animation player, which is under flip page. We enable and disable this. So when we do it, what we're going to do is, let's just start by checking animating the jumping. So if the velocity dot y is greater is greater than 0, that means if it's in positive, which means it's going down, we're gonna just play animator dot, oh my god, why animator, the animator dot, which is a property, and play. This property just takes and the name of the animation that we name while creating the animation. We're gonna just do fall, because it's going, jump if it's going up, because if it's greater, then it's gonna be jump, and else if it's not that, elif, I'm gonna check for elif. If it's not, then check this thing, which is velocity, velocity is shorter than 0, which is in minus. Then we do is animator, oh my god, animator dot play fall. Simple and easy. Simple and fucking easy. But where's the problem? Oh yeah, velocity dot y, because when we use velocity as a whole, it has two values of type vector 2, but dot y turns it into a float, because our vector 2 has two float values. We'll learn about more of them in later videos. So we got this. Let's just go to the horizontal movement. For that, again, if the direction doesn't matter actually, the velocity dot x, which is the horizontal velocity, is greater than 0, then we if it's greater than 0, shorter than 0, that means it's in negative, which means it's going to be right. Animator dot play the hell run. I mean, you can just check it's greater, but we can just check if it's not 0. For y, if it's not 0, not equal to 0. Now, but that means if it's just moving, because flipping, we are all doing all the flipping up here. We just want to check if it's moving. If it's moving, run. And if it's not moving, then you can just do else if its velocity is equal to 0, equal, which means equal to the value right here, 0. And no, let me just explain these more. Now, equal means checking for equal. If you add one equal, that means it's assigning value to 0. I hope you understand that. Just basic mathematics. I hope your teacher taught you that. You dork. Oh, okay. So what we need to do is we just play animator. Oh my god! Fuck. Why do I type this? Animator dot. Okay. Brace yourself. We're almost writing the last lines of code. Okay. Dot play. And duck idle. Oh yeah, we fucked up somewhere. Yeah. Oh yeah. Again, the velocity dot x. It's a vector 2. And yeah, I think it should work. Since we are calling the function already, it should be working. That means animate. It does what it says. It animates, and we're giving the value of the direction variable here to it. And that direction variable is assigned to the stir, which we are using here to flip it or not. And let's go ahead and run it. And I hope it does work. And what do you know? It's moving. It's moving too fast, so you cannot see the. So let's just let's see speed to 100. Yeah, it should be fine. And it's walking. Yep, the guy is walking. It's walking. It's walking. Yes, it's walking. And yeah, that's kind of it for today's video. I know a bit of a long one because yeah, I've been jumping for a while. And yeah, and I'll see you in the next one. If you like my work, and I mean, to be honest, I spent too much time explaining basic stuff, and you can just support me on Patreon. And once we are done with this game, which is going to be a full game, Mario-like, I'm going to be giving the code to all the patrons, and you can just support me with as low as $1. Come on, I'm broke. Okay, so I'll see you in the next one.